All right. I hope that you already read all the questions. Yes, I started.
In the last tutorial, there was like 9 students, and it was very difficult to, like everyone is asking question on none as well, and everyone asking in the class question. No, yeah, I know, but he was there. I think we need one more. Yeah, I will ask to the Sagar.
Okay, guys, let's at least read the question together and to see whether we all understand the questions first. Then I will assign the questions to your group. Okay, as you can see here, question 1, I hope you already checked with the TAs. If you haven't done so, he will come to approach you. Question 2, you're riding a bicycle, okay, at the speed of 10 meters per second. A pedestrian stepped out, all right, in front of you 10 meters away. All right, so in this question, then you start to slow down. So what is the scenario here? If I'm the one riding a bicycle, I start right here, okay, at the speed of 10 meters per second. And there's a person, let's say that is here, 10 meters away from me. So I start to slow down, decelerate immediately with the value of 10 meters per square second. So the question is asking you, am I having enough time to stop? So what happened here is I slow down. There will be 3 scenarios here. The first scenario is with the initial speed 10 meters per second, I will slowly slow down. When my velocity equals to 0, actually already passing. In this scenario, I will hit him. Am I right? Second scenario is I start to slow down. When I reach him, my speed equals to 0. So this is a scenario that my velocity equals to 0. So I barely did it, right? So the last scenario is I start right here. I try to slow down, and stop here. And he's ahead of me. So it means that I still have a good margin. I didn't hit him. So the question asks you whether in this scenario, in this question, which scenario it will be. So you have to find out the parameter that you need to compare in the 3 scenarios. So for this question 2, can I assign the group these 2 tables to work out? And one of you need to tell us answer at the end of it. Question 3 is the difficult question. I want the group to volunteer yourself to take this question. So in the question 3, a student throw a key. All right. So with the initial velocity, throw a key, and your friend grabbed the key 1.5 seconds later, and the distance between you and your friend is 4 meters. Okay, in this question, they ask you, without calculation, what do you expect the velocity, the key, to be just before they are caught? So there's a 3 options: 0, positive, and negative. This represents 3 different scenarios. If the velocity equals to 0, means that the key toss out, you catch it when the velocity equals to 0. Scenario 2, positive, means that the key toss up is slowed down, but on the way, reach to the highest point, you catch it. Your friend catch it. The next scenario is negative, means the key go up and stop and coming down. So this is the 3 different scenarios. The question B asks you to calculate the following: initial velocity and the velocity of the key just before they were caught. This gives you a hint that we don't know the initial velocity. We don't know the final velocity. So you have to use the equation to solve it, find out what is the right scenario. In this case, we only know 2 parameters here. One is a free fall. So the acceleration equals to 9.8 meter per square second. Second, the second parameter we know is the time is 1.5 seconds. So these are the 2 parameters we know. Rest of them we don't know. Okay, don't make the assumption by yourself. So which group want to take this question? Do we have volunteers here? Okay, group here. So the 2 groups, 2 tables, can you join them to discuss question 3? Okay, at the end of it, I want one of your group members to explain it to me. Question 4 is very simple. So we have a driver drives for north to north for 35 minutes for 85 kilometers per hour and stop for 15 minutes, then continue to drive in the same direction, 130 kilometers in 2 hours. Question 1 is to ask the total displacement equals to the displacement of all added together. And the second one is what is the average velocity. So you need to find the right formula to solve it. Okay, so question 4, can we ask the group here? 1, 2, 3, 3 tables. You try to solve it and tell us the answers later. All right. Last question. A ball is thrown vertically upwards. Okay, very simple questions. One is what are the velocities and accelerations when it's reached the maximum altitude? And the B, what is the acceleration of the ball just before hits the ground? So can we have the last group there to solve the question 5 first? Once you solve your group question, please continue to solve the rest of questions. We will start to explain all the questions in 10 to 15 minutes. Once you finish question 4, continue with 2. I thought I'm going to get the answer now. Can you answer now?
So first, we just give.
You all get the right? So, just come here. Then discuss by yourself. This is the trickiest question.
I know.
Yeah, we'll get the crack
You volunteer, right?
Online.
Yeah. I also.
To check what question do you want to stream?
It's a good thing you can type fast. Oh, he's coming.
नहीं ये 2 कर रही है, ये वो भी करती है 200 लेवल इंजीनियरिंग पे इंजीनियरिंग.
We'll come back at 3. You're so good at typing, Pratik.
Yes.
This is working himself. This is
Yeah.
Yeah. You'll get it written in no time.
So. सागर ये इसके ऑनलाइन अटेंडेंस की तो लेनी है.
आप होना चाहिए वो रिकॉर्ड तो कर रहे हैं ना. बोला ना प्रोविजन वेयर यू कैन शो ऑटोमेटिक अटेंडेंस.
मेरे पर कर ले यार, इसको डायरेक्ट नहीं डाल देंगे कल. ये तो चालू शिट
कैन ले आओ तो
So it's about how far 10 meters relative to the room. Yeah. How fast is 10 meters per second in kilometers per hour? Just times it by 3.6, so 36 kilometers per hour. Without being associated with this, whether you think they would stop in time, we thought that yes, they would stop in time. Drawing a diagram, we just basically drew a velocity over time graph starting at 10 meters being your initial velocity, time being 1 second, and we just needed 2 points. What information do we have? We have the initial velocity, the acceleration, the initial distance being 0, and the final velocity being hopefully 0. The variables that we needed to work out were the time and the final distance that they traveled before they managed to stop. So after that, we first worked out the time. So that was final velocity equals initial velocity plus acceleration time. Rearrange that. So final velocity minus initial velocity over acceleration equals time. So that ended up being 0 minus 10 divided by 10, which is 1 second it took them to stop. We then put that in the equation for the final distance, which is the final distance equals the initial distance plus initial velocity times time plus half acceleration times squared. And that ended up being 5 meters. So they stopped with 5 meters to go before that they hit the person.
So you see the key point here is to find the displacement. So he mentioned 5 meters is less than 10 meters here. Okay, so very good. This is the right answers. So I try to summarize the solutions here. So what we have here, if you are not familiar with the motion in the 1 dimension, please draw the diagram. So let's define this is the positive x-axis. Let's define this place as our initial place. At the initial place we have SI equals to 0. VI equals to 10 meters per second. We know TI equals to 0 here. As I just explained, there's 3 scenarios. You will hit him, or you barely miss him, and you have a margin to miss him. So let's forget about it. Let's calculate what is the displacement when I reach the final point. Our VF equals to 0. So we don't know what is the displacement here. We also don't know what is the time here. Am I right? So what we know our acceleration here equals to negative 10 meters per square second. So as he just explained the formula, which formula we can use? There's 3 formulas which repeatedly appear in this week. So one of them will be XF equals to FI plus VI delta T plus half AX delta T squared. Look, in this formula, in this equation, the only unknown is the final position here. We know this equals to 0, 10. Okay, delta T, how can we get the delta T here? Yes, because we know our VI and the VF. We know AX. We have VF equals to VI plus AX delta T. From this equation, we will be able to find out what is the AX here. Oh, sorry, delta T here. 0, 10, negative 10, simple, equals to 1 second. So this is the 1 second. Okay, negative 10 and 1 here. You will be able to find out what is the final distance, which equals to 5 meters here. 5 meters is less than 10 meters. which means I can stop in time. When I stop, he's still 5 meters ahead of me, right? So well done. This is question 2. All right, the trickiest question 3. We have a representative here. Question 3. So let's look at the questions. I throw my key. Okay, it's go up and down. But 4 seconds later, my friend will grab the key, and the distance between me and my friend is 4 meters. All right. So let me explain the question a little bit more using mathematical model. So this is a free fall. So if this is a full free fall, what will happen is here. Start from here. Okay, we know why this is along y direction. We design the positive direction is point up. All right. So in this case, our initial displacement equals to 0. Vi unknown. Ti equals to 0. Okay, if this is a full free fall, what will happen? The key will go up and reach the position here, V equals to 0, and coming down. So this is the full free fall equation, full free fall motion. And we don't know what happens, okay? What we only know is at some point, any point along the motion, we have our TF equals to 1.5. We have our YF equals to 4. We don't know our velocity here. Okay, you look at what we know, what we don't know. Look at the formulas, 3 formulas in this week. Which one do you think is useful to help you to find the unknown? The unknown here is the final velocity. The unknown here is the initial velocity. So look at 3 of them. Any suggestion? This one? Free fall. What we know? AY equals to negative 9.8 meter per square second. Look back the equation. We know 0. Do we know this? Okay, we know this equals to 4. This is unknown. 1.5. Negative 9.8. 1.5. The only unknown in this equation is the initial velocity. Okay, later on when you solve to find out the unknown, one unknown, you need one equation. If you have n unknown, you need to have n equations here. So only one unknown is the initial velocity, Vi equation is here. So by solving this equation, you will be able to find out the velocity equals to any suggestions? What is the initial velocity here? 10 is the correct answer. But you know the equation, I'm sure you can find it out later. Okay, so from here you can find out what is the VF equals to VI plus AY times delta T equals to negative 4.7 meter per second, which tell you that which scenario is that. The key is going up, become 0, and reach and coming down. So this is the scenario. So it's happened here, go up, and halfway going down, and your friend caught the key. All right. Another suggestion of this question is you can make assumptions. If you are kind of lost, you can make assumptions assume your VF equals to 0. But you have to prove your assumptions here. If you make final velocity equals to 0, you have to check. What do you need to check? You need to check what is the final displacement in this case equals to which equals to 11 meter, which is more than I equals to 4 meter. This tells you that your assumption is wrong, right? So if you make assumptions during your solution, in your solution, please prove whether your assumption is valid. All right. Okay, so you know the equation, you should be able to find the answer. Next one, question 4. Okay. A motorist drivers drive to the north. So here, all the way to north. Okay, so we can draw two diagrams. One is the displacements versus time. Okay, displacements versus time t and displacement. All right, so from 0 to T1 is 35 minutes. Okay, you drive at the distance 85 kilometers per hour. So this is velocity. So we can have another one is called velocity versus time. So let's say AT right here. We stopped for 15 minutes. So from here to here, this is 15 minutes. Stopped means the velocity equals to 0. So what is the link between the velocity and the displacement? Displacement equals to the velocity times the time. So from 0 to 35, there will be an increase of the velocity here. Then stop for 15 minutes. Stop for 15 minutes means there's no displacement as well. So we'll maintain the distance displacement for 15 minutes. And we'll continue in the same direction, traveling 130 kilometers in 2 hours. So will be, let's see, this is Y1. So this is Y3 or X3. So the distance between these two is 130 kilometers. Right? So 2 hours. And you look at your velocity versus time graph. From here to here, V will equals to delta x over delta t. 130 kilometers per 2 hours, which gives you 35 kilometers per hour. Okay, so we have from here to here is 75 kilometers per hour. So these are the two graphs. Okay, the group, can you tell us the answers? Which one?
All right. So first question is, what is total displacement? And for that, what we did was we broke down how many kilometers per minute we traveled, which was right? 1.42 kilometers per minute. It's more than that, but it was outside significant figures. Then we multiplied that by 35 minutes. That gave us a nice crisp 49.6 kilometers. And then we add on the other 130 kilometers to give us total displacement, giving us 179.6 kilometers.
All right. So the second one.
Second one, that's what the average velocity is. So again, we have to break it down into kilometers per hour into meters. So I'm sorry, kilometers per hour into minutes. So we divide 179 by 170, and then multiply it by 60, give us back to hours. So we divide the full displacement by minutes traveled and multiply it back into 60 to this hours, giving us 63.4.
Correct. So the trick here is we have the unit of minutes and hour mixed in the time. So you have to use one. If you don't know which one, you can't make a decision. You know, some people just have trouble to make decision. What do? Convert everything to SI unit. SI unit for the distance, for the displacement is meter. The SI unit for the time is second. So you can do that and find the answer. But in this question, you can also use kilometer per hour, right? So the first one is how many minutes? 35 minutes. 35 minutes over 60 is the hour. Second one, 15 minutes over 60 is the hour. Last one is 2 hours. Okay, so this is with the unit of hour. So as a result, you will get 63.4 kilometer per hour here. You can also convert it to meter per second.
What is the sign delta means? What is delta means?
Delta is the displacement, the difference. Delta usually represent the difference. So x is the position. Delta x is the displacement. So that's a very good point. When you want to find the velocity, it's not the position over the time, it's the displacement, the position difference over the time. All right, last one. Well, simple one. A ball is thrown vertically upwards. What are the velocity and acceleration when it reaches its maximum altitude group?
Well, the next velocity for the acceleration.
Yeah, so it's a free fall, right? A ball thrown up, reach its maximum altitude. So again, what is the velocity?
0.
So V here equals to 0. What is the acceleration? Exactly, it's a free fall, it's a constant. So if I define this as a y-axis point up, so acceleration here will equals to negative 9.8 meter per square meter here. Another question is just to enhance your understanding. What is the acceleration of the ball just before it hits the ground? So when they reach the maximum, we're coming down. What is the AY here? Any change?
No.
Exactly, no change. So equals to negative 9.8 meter per second here. Great. That's all the answers to the tutorials. Any question?
Was quite fast.
Yeah, we have 5 questions here. Okay, so every time before you come into the tutorial, try to attempt all the questions. If you don't understand, at least read all the questions before you come into the tutorials. Prepare yourself. If you have any questions, do approach us. We have 2 help sessions.
We have 2 help sessions on Monday and Tuesday, 5 to 6. So you can come with any query related to lecture, tutorial question. It's face to face, so you can ask questions to us.
This is your time to short.
Actually, we have a problem with this third question that you're explaining because you're asking them to substitute VF0 in this equation, right? You cannot substitute VF because it is VI.
No,
You can't substitute VF in this. What you can suggest them is substitute here, calculate VI, then substitute here to
no,
calculate
no.
YI.
This question is to find the VI.
Yeah.
It's not.
No. The equation is for that, but you are asking to cross-check the assumptions, right? You're asking them to check the assumptions. When you're
No, it's here.
yeah, you can't substitute VF.
No.
in this equation.
I asked them to assume,
Yeah.
right?
Oh, you can
So
keep
we
that.
assume, then you can find
But this is
YF. So that's why I see it's 11. It's more than 4. It's wrong.
the equation doesn't have VF in this. Okay, what you can do is you can substitute VF in this.
Oh, no. Wrong equation. I asked to substitute here.
Okay. Thing is, this equation doesn't have VF.
Yeah. So you can use that.
You can't use this.
When you make assumption VF equals to 0, you can't use that.
Okay, just check with Mike. The thing is, you can use VF to calculate VI first, and then use the VI here. Okay, and then you'll get your 11.02. The thing is, you're
Yes.
leading them wrong by telling them to substitute VF in. You can't substitute VF in.
No, I thought I used this equation.
No, this is the second equation. There is two-step process. You're missing the first step.
So these are the 3 equations.
Right. See, is there a VF parameter in this? Not there.
No,
Yeah.
I'm not using this one. I'm using this
But
one
you
for
are not
assumption.
mentioning. You're not mentioning them to use this. You're directly telling them to use the VF in this. That's how you told in the previous tutorial as well as in this tutorial. They wouldn't know unless you
Oh,
suggest
I
them.
know what you're trying to say now.
Okay, so you can't.
No. I try to tell you, this one is right to find this, but they have to understand is, you know, you toss the thing in outside and the coming down is the same distance, right?
Yeah.
I mean, it's just a second step to think why I can use this equation. It's the right equation, but you are right also. They may not understand why
Yeah,
we use
because
that.
the thing is, that's how it is understood. Even in the last tutorial, you mentioned them. You use this, and then you actually specified that substitute here, like, and also here you simplified the equation. So it is conveying them the message like you can substitute VF there. But the thing is, there is no VF parameter in that equation.
Yeah, it's just a look downward.
Yeah,
So,
yeah.
yeah, you're right. I just forgot. It's just, all right. Thank you for volunteering. See you next week.